Hi there, this is my 5th video on Bolt, and in this video we're going to look at recycling game objects. So in the last video we finished off with our spawner that procedurally generates all the trees in front of us, and now I want to use those instantiated 100 objects and recycle them, placing them in front of the tractor. So first let me decrease the number to 10 so we can see it work better. And now what I need to add to my game is a way for me to know when the trees are off screen. And the trees are going to be off screen when they're behind the tractor. One way we can check is by adding another game object to our player. So let's create an empty and rename it to off screen. So let's go to the inspector, and for this game object, the only thing that I need is a box collider. So turn on is trigger. And let's adjust our shape. I want to scale it in the X position to cover the whole area in the X position. And I guess we can scale it up in the Y position. Now, currently the position is at 0, 0, and I want it to be behind the character. So let's move it by -7, something like this. So that's the setup for the off-screen sensor. And now we're ready to create a graph for our off-screen sensor. So let's click Add Component. Then go to Bolt, we'll add a flow machine. And also for this one, we're going to use an embedded flow machine. Add a graph. We won't be using these events. And the event that we're going to use is the if collide that we created in part 3. So we're looking for collision with tag enemy. Once that collision happens, we want to throw an event. Under event options, the only event we have is the trigger custom event. And this event has string input, which we can use to specify the name of the event. So let's call it Relocate. And then we have the input for the target event. And here we want to pass in our trees as the target. So we'll have to find the trees object. And we can check that in game object and find. Let's select that. And we just need to pass in the name. And the name is trees. That will find our game object trees and pass it in as the target for our event. Also at the top right here, we have the options for the amount of arguments, and I want to add one argument. And for that argument, I'll pass the object that it was collided with. That's the whole setup that I needed to do for the off-screen game object. And now we need to implement this logic in our trees. So in our trees, we need to find that custom event. So here's the custom event. We're getting one argument from it. The target is self and the event name is relocate. Okay. And once I get the relocate, I want to set position. So let's look for set position, and we're looking for the set transform position. The target, we need to change from self to use the argument instead. And the position that we want to set is from the same calculation that we were using for instantiation. So let's connect that position. And the last thing we need to do is trigger the Z position increment. And that's pretty much it. Now if we click play, you can see that the trees are actually being deleted. So we started with the 10 trees and now all of the trees are gone. And the reason why that happens is because our player has a rigid body and our off-screen does not have a rigid body. So in Unity, both those box colliders are going to trigger the same collision logic. And if you remember in our player, we have this if collide that destroys the object. And although both of the if colliders inside the player and the off-screen run, the only one that we actually see is the destroy one, because it actually removes it, so we can't see it move. And if you want to separate the triggers for the player and the one that we created for the box collider, you need to create another rigid body for the off-screen. So we'll do that. Let's create a rigid body, turn off use gravity, and we'll set it to be schematic. Now, after that, if we click play, you can see that relocation logic works, but if we collide with any of the trees, those trees still get removed, and that's not what we want. And we want to switch the logic for the player from removing to relocating. So we'll remove this destroy, and here we'll connect the event, the custom event, one argument, relocate is the name of it. We pass in the object as the argument, and instead of self, we want to find the game object, and the game object is trees. So now on collision, we'll also relocate the tree. So now that we see that it's working, we can go to our trees and increase the count so that we won't see the end of the trees, and it would seem that the trees were there all along. So set it to 100, click play. So there we go. We've finished the procedurally generation of our trees and implemented the recycling of game objects with Bolt. That is pretty cool. Now I have a little bit over 10 hours before Bolt Game Jam submissions are due. I still need to edit this video, and after that, whatever time is left, I'll try to make a playable game, and I'll make a video about whatever will come out in 10 hours. So thanks for watching, click on the like button, and I'll see you in the next one.